Are you a student struggling to keep up with your lessons? Or a parent searching for a reliable educational resource that truly cares? You've come to the right place. Welcome to FEUNIX Distinctions, your premier channel for educational content designed for every learner. We understand the silent struggles that often go unnoticed, the frustration of slow-paced learners, and the need for solid foundations for all students. At FEUNIX Distinctions, we don't just teach. We are dedicated to guiding you every step of the way. Our teaching style is unique, simple, and incredibly effective. We make complex concepts easy to grasp and ensure that every lesson is both suitable and enjoyable, no matter your learning pace. Whether you're a fast learner looking for a new challenge or an average learner aiming to excel, our comprehensive methodology is built to support you. Join a community where no one is left behind. Subscribe to FEUNIX Distinctions today and hit the notification bell so you never miss a lesson. Let's make learning an exciting journey together.
I welcome you all to today's class, SS1 Mathematics. Lesson 8, our topic, Logarithm. That's the topic we are treating, and we are going to continue. I remember in the last class, Lesson 7, we were able to solve some questions that have to do with multiplication and division. And we said whenever we have two logarithms multiplying themselves, what you have to do to the logarithm is to add them. And when two logarithms are dividing themselves, what you have to do is to subtract the logarithm. So we are moving forward. We are going to see today's subtopic. But don't forget, we have our tables here. The white table we have here is our logarithm table. This is the logarithm table. If you scroll down, you will see another table here, which is the anti-logarithm table. We're still going to use these tables today. Alright. So our subtopic is powers and roots. Powers and roots. Powers and roots of logarithm. In lesson 7, we saw multiplication and division. Now we want to see powers and roots. In multiplication of logarithm, we add the logarithm. Division of logarithm, we subtract the logarithm. Now powers, if we have power, what are we going to do? And if we have roots, what are we going to do? That's what we're here for. So let's solve examples. Example. Evaluate 1. 3.55 raised to the power of 4. Yes, example 1 have to do with power. Power 4. 3.55 raised to the power of 4. Then example 2 is going to be roots. We want to handle questions that have to do with power and roots. Now let's move into our work. First thing, we draw our lines. This side we have the number, this side we have our logarithm. The number here is 3.55. We're going to check the logarithm of this number. After that, we now consider the power. What do we do when we have power? Let me say it even before, ahead of time. Whenever we have power, we multiply the logarithm with the power. Whenever we have power, we multiply the logarithm with the power. And anytime we have roots, we divide the logarithm with the roots. So basically we have 4 laws now. Multiplication and division, power and roots. When you have multiplication, you add the logarithm. If you have division, you subtract the logarithm. If you have power, you multiply the power with the logarithm. And if you have root, you divide the logarithm with the root. Let's move on. 3.55. Let's check for the logarithm of 3.55. The first thing is to get your integer, and we say integer is how many times the decimal will move to 4 before the first significant figure. This is the first significant figure here, 3. 3 is the first significant. How many times? The decimal is already there. From the question, the decimal is already before the first significant figure. So the decimal will not move at all. Since the decimal will not move at all, you write 0 and put point. Why do we put 0? Because the decimal did not move at all. Supposing the decimal is around here, then it will move once. And then what are we going to put? We'll write 1 here because it moves once. But now the decimal is not moving at all. That is why we write 0. 0 means it did not move at all and put point. Step 2, we'll check the logarithm. 35, we'll check 35 under 5. So we'll scroll to the logarithm table and check 35 under 5. This is 35 here. This is 35. We'll check under 5. Under 5. So from this 5, we'll be going downward. We'll be going downward. So if you are checking from here going downward, and you are checking from here going horizontally, you will see that they will come and meet. They will come and meet here. They will meet here. So what's the number we're seeing there? 5502. 5502. You come and write it. 5502. Now remain the power 4. What do we do to power? We multiply the power. Whenever you have power, you multiply the power. So you have to press your calculator. 0.5502 times 4 will give you 2.2008. Now we are moving to the last stage. That is, we are going to check anti-log. In checking anti-log, we don't use the first number. We start from the decimal here. That is, we'll check 0.20 under 0, difference of 8. Let me find somewhere to do this. 0.20 under 0. 0.20 under 0. This is our anti-log table. This is 0.20 here. This is our 20 here. 0.20 is here. 0.20 under 0. This is under 0 here. 0.20 under 0. Check it, you will see 0.20 under 0. You will see this value here. That is 1585. You see 1585 there. 1585. Let's write it. Let me do the work here. 1585. 0.20 under 0, 1585, difference of 8. Let's go to the difference table. This is the difference table here. From here downward here, down to this place is the difference table. You will see it written there. Difference. This is difference 8. This is difference 8 here. This is difference 8. So when you check difference 8 down under that 0.20, under that 0.20 that we have here, you will see that they will meet somewhere here. They will meet somewhere here. And what's the value you are seeing here? The value you are seeing here is 3. 3. You will now add the 3. Let's add the 3 plus 3. 5 plus 3, 8. We have 8 here. We have 5 and we have 1. That is 1, 5, 8, 8. Now let's complete our work. Is now we are going to make use of these 2. This 2 is telling us the number of times we'll move our decimal. And at first, we'll place an assumption. We'll place an assumption that the decimal is at the standard form. That is, the decimal is already after the first significant figure. Then 2 means move it 2 times. This is the first significant figure. This is after the first significant figure. You will just move 2 times. This is 1, 2. Now our answer will be 158.8. We move 2 times. The decimal is here. That's our answer. Let's solve the second example. Example 2. Evaluate 5 roots 40,000. 5 root 40,000. We'll draw our lines again. We have our number. We have our log. 40,000. What's the first thing? Is to get our integer. The integer is the number of times the decimal moved to be at the standard form. And standard form is the decimal must be before the first significant figure. This is the first significant figure here. So the decimal will definitely come to this side. And where's the decimal? We said if decimal is not written, consider it to be at the extreme end. Like this question now, the decimal is not written. So consider the decimal to be at the extreme end. Keep moving till it falls before the first significant figure. This is the first move. 1, 2, 3, 4. Write your 4 and put your decimal points. We have gotten the integer. Stage 2, we'll go to the logarithm table and check 40 under 0. 40 under 0. Let's scroll to the logarithm table. This is 40. This is 40. 40 under 0. 40 under 0. 40 under 0 will give us 6021. 6021. Here is it, 6021. We'll come and write it. (6021). Remaining this roots 5. We said if we have roots, we divide with the root. So 5 roots 40,000. Now we're going to make use of this 5. Divide by 5. 4.6021 divided by 5. You press your calculator, you have 0.92042. We only need 4 figures here. 1, 2, 3, 4. We don't need the fifth one. So if the fifth one is a number that has to do with 5 or anything above 5, we will round this one up. But if it is anything less than 5, this one remains. We are rounding this one up, it will have become 5. But since this number is not up to 5, this one will remain 4. So I want to rewrite this number. This will be 0.9204. So with this number, I can check the anti-log table. Anti-log table now, I will check 0.92 under 0. 0.92 under 0. Let me do the work here. Anti-log table 0.92 under 0. This is 0.92. This is 0.92 here. This is 0.92 under 0. Under 0. 0.92 under 0. So if you check this going down, you will see 8318 here. 8318. 8318. Then you write your 8318. 8318. Now difference 4. Go to the difference table. Here's the difference table, difference 4. This is difference 4. You check down. Check it down to that very number. Difference 4, you will see 3. When you check difference 4, sorry, you will see 8. Look at it here. It's 8. Difference 4 will be 8. You will now come and plus the 8. Here's our 8. Let's plus it. 8 plus 8, 16. Write down 6, carry 1. 1 plus 1, 2. We have 3 here. And we have 8 here. That gives us 8326. 8326. Remaining the final answer. We are going to check this very integer. That's what we are going to use. As usual, we will come to the number we have. We'll place an assumption that the decimal is after the first significant figure. Then the number we have here will tell us how many times we are to move the decimal. So by assumption the decimal is here, we are to move it. And the number we have here is 0. 0 means we are not moving at all. So since we are not moving at all, you will just print the decimal there. Supposing we have 1 here, we will have moved the decimal once. But the number is 0. 0 means we are not moving at all. So you just print the decimal out there. So our answer is 8.326. That's our answer. So at this point, I'm going to leave you with work. You are going to do this assignment for me. Evaluate the following. Evaluate the following. 1. 9.21 raised to the power of 4. Please do this work. If your work is correct, your final answer will give you 7,200. Question number 2. Evaluate 82.5 raised to the power of 2. If your work is correct, you will get 6810. Question number 3. Evaluate 5 roots 93.6. Your work is correct. The final answer will be 2.48. Question number 4. Evaluate 3 roots 1630. Your work is correct. You answer will be 11.8. The last question, question number 5, we have to evaluate open bracket 184.8 all over 6.2 close bracket raised to the power of 3. Your work is correct. Your final answer will be 26500. So thank you. Do well to click the subscription button, click like and share so that you will get informed when the next video is out. Thank you and have a nice day.